Going over the question of the quiz first. Make sure you have no difficulty when you want to repeat it again for us. Okay. So this is going to be quiz number 4. Solution to that quiz first. So in the first part, you've been asked to write the first 4 terms of each sequence. So that's number 1, part 1. The sequence is an equal to the 5n minus 2. You just substitute n equal to the 1, 2, 3, and 4 to get the result. So a1 is 5 minus 2, which is equal to 3. Okay, a2 is 5 times 2 minus 2 is going to be 10 minus 2, which is 8. Then a3 is going to be 5 times 3 minus 2, 15 minus 2, which is 13. And a4 is going to be 5 times 4 minus 2, which is 20 minus 2, which is equal to the 18. So the term of the sequence are going to be, are going to be 3, 8, 13, and 18. So these are going to be the first 4 terms of the sequence. That's part 1. Any question? So we give just, a couple of them again. Part B, the general term of the sequence is an is 24 over n factorial. So first 4 terms. So if you want to find the a1 is going to be equal to the 24 over 1 factorial. 1 factorial is 1, so 24 over 1 would be 24. That's the first term. a2 is 24 over 2 factorial. 2 factorial is 2, so that gives you 12. Okay, a3 is going to be 24 factorial over 3 factorial is going to be 24. You know that 3 factorial is 3 times 2, which is 6. So that gives you 4. And a4 is going to be 24 over 4 factorial. Okay, 4 factorial is going to be 1, 2, 3, and 4. This is 6 times 4, 24. So 24 over 24 is equal to the 1, and we're done. So the term of the sequence is going to be 24, 12, 4, and 1. Okay, so that's number 1. Any question? So the second part is recursively defined. For the final, we usually give you one only, but we put them together. So number 2, part 1. Part 1, recursively defined. The sequence is an equal to the 5an minus 1, and start with the a1, which is equal to 2. So each term of the sequence is 5 times the previous one. Okay, an minus 1. So if you put the n equal to the 1, we have to start with the 2 because the 1 is already given. So a2 is going to be equal to the 5a1. Okay, the previous one. So a1 is equal to 2, so 5 times 2, which is equal to the 10. This is going to be the second term. So the third term is going to be 5 times the previous one, a2. So it's the 5 times 10 equal to the 50. Okay, so a4 is going to be, this is it, a4 is going to be 5 times a3. So it's going to be 5 times 50, which is going to be 250. So the fourth term of the frequency is going to be 2, 10, 50, and 250. So these are going to be the term of the sequence, and be done. Okay, they ask for the 4 terms, so we give them the 4 terms. Any question? Part B is like the one that we did. an is an minus 2, an minus 2 plus n times an minus 1. And the 2 terms are given to you. Is the a1 is equal to the 1, and a2 is equal to 3. So carefully substitute to get the others. So we have 1 and the 2, so we go with the 3. a3, replace the n by 3. 3 minus 2 would be 1. Okay, plus replace the n by 3, that give you 3a, n minus 1 would be 2. Okay, so a3 would be a1 plus 3a2, substitute. a1 is equal to the 1 and a2 is equal to 3. So that give you 10. Okay, it's just a substitution. So the a4 replace the n by 4, that give you a2 plus n 4 a n minus 1, which is going to be a3. Okay, then you substitute your a2 is equal to 3 plus 4 times the a3, which is 10. So that give you 43. So the fourth term of the sequence is going to be 1 3. Okay, it is going to be 1 1 3 10 43, etc. So that give you the terms of the given sequence. Any question? So we call them recursively defined. You see, the term of the sequence depends on the sum of the superior terms. So that's a number 2. Number 3, just the application of a geometric series. For number 3a, they ask you to change the 0.7 bar to a common fraction, but we want to use geometric series to do it. You know that this means it's going to be 0.777.
Excuse me.
Yes,
Uh,
what's the question?
on 2B, the quiz that I had said that the first, it was a to the n minus 2, not n minus 1.
N minus?
On 2B, it says a to the nth equals a to the n minus 2 plus n minus 1.
That's it. That's the way I have over here.
Oh, I thought you wrote n a to the oh, never mind. Sorry. I got
Okay,
confused.
that's fine. Okay, so this is going to be, so this is 3, part 1. So we have to break this one as an infinite sum. Okay, so the infinite sum is going to be the zero point 0.7 bar. Okay, we write it down as a zero point 0.7. Okay, plus we need to bring another 7 here, so we have to make a room for it. Okay, then another 7 here, so make a room for it, etc. Okay, so this is going to be like a 710, the first one. Then we get the 700 and the 7,000. So as you can see, we divide by 10 to get to the other part. So this is going to be a geometric series with the first term, a1 is equal to the 710, and the common ratio of 110. Because if we divide, one of them by the other one, 1 over 100 over 110, that gives you 110. Okay, which is less than 1. So we know that this series is going to be convergent. Okay, it's going to be convergent, and this is going to be S infinity, if you like. So the S infinity is going to be equal to the A or A1 over 1 minus R. So that gives you 710. 710 over 1 minus 110. So that gives you 710 on the top. That's like a 10 over 10, which is going to be 910. Then you simplify it, that gives you 79. So zero point 0.7 bar is going to be equal to the 79. Okay, that's a nice application of a geometric series. Any question? So as you go on, if you add these numbers together, that gives you 0.7777. But we can rewrite it as infinite sum because it's going on forever to get these numbers done. Okay, so that's the number 3. Part 1. The part 2 is just a notion of the factorials that we want to emphasize. Okay, so it's a 3 factorial, 5 factorial over 6 factorial. you want to simplify it, the way to do it, we can do it right away, list the members, or just note that this is 7 factorial, 5 factorial, and that's a 6 factorial. List the elements, you simplify it, or it's a 6 factor, 6, 1, 2, 3, 5, 6. You can write down as a 5 factorial, then times 6. So these two quickly would be cancelled out. We get the 3 factorial over 6. 3 factorial 6 over 6 is equal to 1. Or you can evaluate it to put these numbers, the numbers together. Any question? So that was just for, just to think about it. We are not going to give you anything on the final, but we give a factorial, of course, but not is to simplify it. Okay, next, the interesting one is going to be number 4. What's the number 4, part 1? A geometric sequence is given. Okay, the term of the sequence is 1/2, then the -3/4, and the 9/8, etc. And you've been asked that this is a geometric sequence. They ask for the nth term, the general term of a sequence. Okay, so the first term is equal to the half. Okay, the common ratio is going to be, if you want to find it, you divide the second one by the first one. Okay, which is a -3/4 times 2/1. If you simplify it, that gives a -3/2. Okay, now the general term of the geometric sequence is a1 r to the n minus 1, the formula. You just substitute. So the a1 is 1/2, and the r is -3/2 to the n minus 1. So this is going to be the general term of the nth term. Okay, this is going to be the nth term of your geometric sequence, n equal to the 1, 2, 3, etc. Any question? We just want to remind you that the general formula that we're going to have. That's the first part. The second part, they ask for the sum, the partial sum, the sum of the 20 terms of this series. So we have the 1/2, and this is going to be -3/4, the same one that we have on the first part. And they ask for the S20, if you like. That's it. The sum of the first 20 term of the sequence. We want to, use geometric sequence. Now list them. We have the formula. Okay, we know from the first part, this is geometric series with the first term of the 1/2, and the common ratio of a -3/4. Okay, S20 is missing. So you know that the Sn is equal to the A1 times 1 minus r to the n over 1 minus r. You have to remember this formula. This is when, when it's a finite sum, you stop somewhere to get these numbers. Okay, now you substitute to get the result. So n S20, so S20 is going to be equal to A1, which is a 1/2, okay, times 1 minus r is a -3/4, okay, -3/4 to the 20, and this is going to be 1 minus -3/4. Okay, you simplify that a little bit. You may use your calculator or just write it down in the simplest form if you like. I want to put it over here. So that gives me S20. Okay, S20 on the top. There is nothing much we can do. You can, if you want to use your calculator, 3/4 would be 0.75. Then you may take care of it. Okay, or just write it down. Is a 1/2 times 1 minus 3/4. Okay, to 20. And down the bottom, I simplify that give 1 plus 3/4. Okay, so that gives you 7/4, if you like, 7/4. You may use your calculator, or just if you want to leave it as is, you can simplify it a little bit. Just use the Okay, use the reciprocal of this one, which is going to be 4, 7. Okay, 4, 7 times 1 half, and this is going to be 1 minus 3 quarter. Okay, 220. So this would be simplified. You get a 2, 7 minus negative 3 quarter, 220. Okay, that would be the final answer. Unless you want to use your calculator to get 0.7075. But this is the best, okay, the best we can do. And if you simplify it as much as you can, we accept it. Okay, so that's going to be 1. What's that? The common ratio? Yes, the common ratio, you're right, was 3 half, yes. Sorry, I missed that one. So that's a negative 3 half. 3 half, 3 half. So that's going to be 3 half. Okay, so that would give us 5 half. That's a 5 half. It's easier to simplify. Sorry about that. 5 half. So this is going to be that's a 2/5. Okay, it's 5 half would be 2/5. Now, if you simplify that, give you 1/5. You may be easier now to use your calculator to get these numbers. But we want just to emphasize that this is not an infinite sum, it's a finite sum. Then you put them together and give us the final answer. Okay, so that is the number 4. Number 5 is infinite series. 2 cases. Are you done? So number 5 is infinite series, and we want to check to see if this series would have a sum. So it's a number 5, part 1. Okay, the part 1 is a sigma of 3 times a negative fifth to the n minus 1. Okay, n minus 1 when n is equal to the 1 to infinity. Okay, this is geometric series. The general formula give you that the first term is going to be a equal to 3a1 and the common ratio of negative 1/5. If you want, you can write at least 2 terms. If you replace n by 1, that gives you 3. And if you replace it by 2, that gives you negative 1/5. Okay, then you will see that the first term is going to be equal to the 3, and the r would be negative 1/5, as is here, a r to the n minus 1. Or if you divide the second term by the first term, that gives you the common ratio of a negative 1/5. So the absolute value of r would be equal to the 1/5 is less than 1. So this means the series, okay, the series converges. So the converges, and we can have the sum of the series. S infinity would be a1 over 1 minus r. a1 is equal to 3, and this is going to be 1 minus negative 1/5, which is equal to the 3, so that you 1 plus 1/5, which is going to be 6/5. So S infinity would be 3, and this is going to be 6/5. You simplify, that's going to be 3 over 1, and this is going to be 5/6. And that gives you 5 half. So the sum of your series, okay, so the sigma of 3 times the negative 1/5 to the n minus 1, n from 1 to infinity, is equal to the 5 half. Okay, so that's going to be the ideal. Any question? So you have to show that, you have to prove that this is convergent, okay? So the common ratio, the absolute value of r is 1/5. 1/5 is less than 1. So according to the theorem that we have, it converges. Then the sum of the series would be a1 over 1 minus r. Okay, the second one, you have a sigma of 2 times 101 to the n minus 1, n from 1 to infinity. Again, if you compare it with the general formula, a1 is equal to 2 and r is 1.02. Okay, we accept it. But if you like, you can write the first term, replace n by 1. So that give you 2, and the 2 times 1.01, etc. Okay, we replace n by 1. 1 minus 1 would be 0. Anything to the 0 is 1. So it's a geometric series with the A1 of 2 and the R of 1.01, which is bigger than 1. When it's greater than 1, the series diverges and the sum does not exist. So the series diverges. Okay, diverges, this means we cannot find the sum. If it's going to be convergent series, then if it gets somewhere. But when it diverges, means S infinity does not exist. Okay, so that's the number 5. Any question? So that's a famous, series and very easy and nice. Number 6 is just a very popular problem, and we give you one. It's it's investment in the bank, or this one growth of the population and employment. It's going to be various version. But basically, this is number 6. The situation is it's known that we have a ton population of 1,000 people, predicted growth rate of 4% for the next 10 years. We want to know what's going to be the population, 10 years from now. Okay, so initially the initial the initial population is 1,000. Okay, you can call this one A0 or A1. It doesn't matter. Okay, with the population of you can call it A0. This is going to be the population originally. Okay, then you have a rate of the 4%. It's not R, it's just rate of the 4% increase, which is going to be 0.04. Okay, and you want to know what's going to be the population of the city after 10 years. This is it. Okay, so the way we are going to investigate this problem is, you see, initially you start with the 1,000. It's going to be 1,000. When we get to the first year, you see A1 is going to be the population originally, which is A0 plus, the percent, 4% of the, 4% of the A0. Well, it's like money in the bank. $1,000 in the bank. After the first year, you get your 1,000 and the interest. So this is going to be like A0 plus 0.04 A0. So that you 1.04 A0. So this is going to be after the first year. It's going to be 1.04 A0. And you can do the same thing for the second year. If you go to the second year, it's going to be the population into the previous year, plus the increase, which is going to be 4%. Increase, again, same thing. So that gives 1.04 A1, but the A1 is 1.0 A0. So this is going to be 1.04, but the previous one is 1.04 A0. You put them together, that give 1.04 squared A0. Okay, then you can continue, get similarly, if you get to the 10 years, it's going to be population, and it's going to be 1.04, 1.04, this is it, they want for the 10 years, this is going 1.04 to the 10 times A0. Basically, the terms are going to be a geometric sequence. It's going to be a geometric sequence, with the first point of the 1,000 and the common ratio of 1.04. But since they asked for the 10, we can write it down right away and get the result. So it's going to be 1.04 to the 10 okay, to the 10 times 1000. Okay, and you can use your calculator to get this number. And so the idea is going to be the okay, each year you see the the the, the the population is going to be the population in the previous year plus plus this new one. When it's a fixed number, it's easy to find, but they usually ask for the general formula, and we have it on the final review. But anyway, this is going to be the one you can use your calculator to get these numbers done. Okay, so that's a sixth problem. A similar one would be given to from this part for the final. That was
I
the
would
yes.
quick question. Was this the one where it was to the n minus one? So would it be
Yeah.
one
If you
point?
want to go it, yeah.
Oh,
You
okay,
want to
it's
find
just a
it.
different way of doing it.
Yeah. If it's fixed,
Okay.
the better one is the one that we're going to talk about in a minute.
Okay.
So they usually ask for for the general formula for the
Mhm.
AN, then they ask you to investigate it after 5 years, 6 years. Okay, but this
Okay.
one is, uh, when it's a fixed, we can guess what's going to be the result. But the nice one is going to be they ask for the general formula first. You will see it. I'm going to check the one on the final review. Okay, so this is going to be the quiz. Okay, for the final review, the topics that we are going to have, and we start from the right at the beginning, just refreshing your memory. These are going to be the things that you should be able to do after this course, really. So the topics that I picked, and we give you one from each. So the first one is just to remind you to solve how we're going to solve an equation with a little bit of fraction. Okay, that's the idea. So that's the final review. So the topic number one is just solving an equation. It's going to be a kind of fractional one. Okay, you have to find the common denominator. So I think I do the part C. The other one are easy. Okay, just to give you something with a fraction. So it's going to be 1 over x minus 1 plus 1 over x minus 4, which is equal to the 5/4. Okay, you know that you have to get rid of the denominator first. So if we find the common denominator would be, okay, the LCD is x minus 1 times x minus 4. Multiply the both sides by this number to clear out the fractions and then just do the job. Okay, so this is it. 1 over x minus 1. So you multiply by x minus 1 times x minus 4. Okay, plus the other one is 1 over x minus 4. Again, we multiply by x minus 1 times x minus 4. And this is going to be equal to the 5/4. And the same thing, x minus 1 times x minus 4. Oh, there was a 4 here. I missed it. Sorry about that. Oh, there is a 4 here. So this must be 4 times. Okay, so you have the 4 times, 4 times, 4 times. Okay, it's a 4 times. I didn't see the 4. Okay, the common denominator would be the product of all the factors. 1, 2, 3 factors. Now simplify. These two would cancel out, so the leftover is going to be 4 times x minus 4. And these two would cancel out, so the leftover is going to be, okay, 4 times this would out. 4 times x minus 1. And on the other side, these two would cancel out. That give it 5 times x minus 4 times x minus 1 times minus 4. Okay, that's it. We simplify it. You get a quadratic equation, you have to solve it. It's going to be 4x minus 16, and this is going to be 4x minus 4. It's going to be 5 times. Use the FOIL method to simplify it. Okay, I just distribute it. So over here, that give 8x minus 20. And this is going to be 5 times it's x squared minus 5x plus 4. So it's 8x minus 20 equal to the 5x squared minus 25x plus 20. Okay, you move everything to one side of the equation, use factoring or quadratic formula. So I'm going to collect them to the other side. So it's going to be 5x squared, 25x plus 20 minus 8x plus 20 equal to the 0. So it's going to be 5x squared. So what we have here, we get the negative 33x plus 4d equal to the 0. Okay, so that's it. You may try factoring or the quadratic formula. You have no other choice to see if there is any solution. Okay, so a equal to the 5, b equal to the negative 33, and the c equal to the 40. So I go with the delta, b squared minus 4ac. So negative 33 squared minus 4 times 5 times 40. So this is going to be the case. Okay, so 333 squared. So that give it 1089. And this is going to be 5 times 420, okay, minus 800. That's it. So minus 800. So that give it 289. What is the square root of a 289? That is going to be, just check to see if it's going to be 289, which is 17. Okay, so it's a 17 squared. So x is equal to the negative 33 plus or minus a square root of 289. Okay, 2 times 5. So we get two solutions. So x would be 33 plus 17, and this is going to be 10. Two cases, 33 plus 17 over 10. Okay, it's going to be 50. 50 over 10, which is equal to the 5, or 33 minus 17 over 10, which is going to be 16 over 10. So that's going to be 8/5. Two solutions. You can also factor it if you want. So we give you one. We have seen this type of problems from time to time, very mild one in calculus, and some people usually forget how to do it. Okay, so one equation, because we have, quite a lot of these type of problems, so why not we check one of them. Any question? That's the first one. The second topic is that famous uh, difference quotient. We give you one to evaluate for us. Okay, so question number 2, difference quotient. We check this. Remember, if you want to take calculus, you are going to be with this formula for the first 4 weeks of that course. So we're going to check it. This is a function, two types of, okay, we did have two types of quotient difference, and we asked for both of them, maybe one or both of them. So the first one, they ask you to simplify this one, f of x minus f of negative 2 over x plus 2. So that's the question. So we have to find them and just simplify it. This is the way I do it. F of x is 7x squared minus 3x plus 1. Then I find f of negative 2. You substitute 7 times negative 2 squared. Okay, minus 3 times negative 2 plus 1. So 2 squared would be 428. Okay, 28, 6, and 1. So that gives you 35. Okay, we subtracted, we did this one before in one of your tests. So we subtracted, so that would give us f of x minus f of 2 is equal to the 7x squared minus 3x plus 1 minus 35. So that gives us 7x squared minus 3x minus 34. Now we divide it by, okay, we divide it by x plus 2, so f of x minus f of 2 over x plus 2. So the top would be 7x squared minus 3x minus 34 over x plus 2. We talk about it, it's always the case that the top is divisible by the bottom. You know that. When it's divisible, there is a common factor, and that common factor is x plus 2. So use this fact to simplify it. So that's x plus 2. There is going to be an x plus 2 on the top. So find the other. The other part is easy to find. This is 7x squared, so this must be 7x. And this is a negative 34. 2 times what would be negative 34? 2 times negative 17. So it's a 7x minus 17 over x plus 2. So x plus 2 would cancel out. So that gives us 7x minus 17, the final answer. Any question? If you are going to be in calculus, one more step, replace the x by negative 2. That gives you negative 31. We call it the slope of a tangent line. Average rate of change, it depends what the application is going to be. Okay, that's the type 1 of the common difference quotient. There is another type that we use for various application. We call it rate of change, and that's the second part. So it's f of h minus 2 minus f of negative 2 divided by h. It's going to be the same thing for applications problem. Two different notation. It takes a little bit more time to find it. Okay, so let's operate this one. Your function is 7x squared minus 3x. So we're going to find what is f of h minus 2. Remember, you think about it, this is going to be in the box. So you drop the box into the function. The function is 7 times box squared minus 3 times the box plus 1. So 7x squared or box squared, h minus 2 squared, minus 3 times h minus 2 plus 1. That is it, okay? You have to simplify it. So a square of the binomial is just the following method. So it's going to be 7 times h squared minus, you multiply these three numbers together, 2 times 2, 4h, plus the square of the 2, which is 4. You distribute this one, negative 3h plus 6 plus 1. You go on. So that gives 7h squared minus 28h plus 28 minus 3h plus 7. You simplify it as much as you can. It's a 7h squared. So this would give you negative 31h and the 35. Okay, any question? Just make sure that when you square it, okay, you have a correct answer. So this is going to be f of h minus 2. Then the other one was f of negative 2. You already find it from the first part. Okay, this is 35 again. So what you're going to do is you are going to subtract it. You see, you subtract, these two would cancel out. So that gives f of h minus 2 minus f of negative 2 is going to be 7h squared minus 31h. Divide by h and simplify. So that gives f of h minus 2 minus f of negative 2 divided by h. And this is going to be 7h squared minus 31h divided by h. Again, this must be divisible. The common factor is h. So we take out the h. So the top would be 7h minus 31 divided by h. H and h cancel out. So the final answer is 7h minus 31. Again, if you replace the h by 0, that gives me negative 31, which is the same as replacing this one by negative 2, that gives me negative 31. So it's the same formula when you are in calculus. Any question? So this is one of those things that, even if you don't want to take that course, these are going to be used quite a lot. Okay, so that's why you must know it. So that's number 2. Number 3 is going to be a piecewise defined function. Remember, we talk about piecewise defined. It's a function that's defined, okay, by several equations on its domain. And we want you to be able to evaluate it or just to graph it. This is going to be part of the case. So this is evaluation on number 3 first. Okay, on number 3, we have the function, which is f of x equal to the x squared when x is less than 2. Then it's a 5 when x is equal to 2. And it's a 3x minus 1 when x is greater than 2. Okay, and they ask you to find it at the following. Okay, at x equal to the 0, 2, negative half, and 5. Okay, so note that this function has been partitioned. When x is less than 2, your function is y equal to the x squared. When it's greater than 2, your function is 3x minus 1. So it depends on your input. You just use either the first formula or the second formula. Okay, locate the 0 is here. For 2 is the partition point. You check it, you see the 2. Then negative 1/5 is here. Okay, and the 5 is in the second partition. So just use the proper formula to find it. Okay, so f of negative 1/5, sorry, f of 0, use the first part. It's going to be 0 squared, which is 0. Okay, then you want to find f of 2. You look to see where the equality is coming. Equality is here. So when x is equal to 2, the function is 5. So let's give you 5. Okay, then f of negative 1/2. Negative 1/2, it's the first partition. So it's going to be negative 1/2 squared, which is a quarter. Okay, and you want to find the f of 5. 5 is in the second partition. So it's going to be 3 times 5 minus 1, 15 minus 1, which is equal to 14. I knew that. Okay, it's important to be able to read these functions, okay, correctly to be able to operate. Any question? So that would be the first question on this piecewise defined. We should have one more somewhere else. Okay, I do that one at the same time so you know the connection between these functions. Okay, the other one is going to be graphing this function, number 11. So graph the, okay, sketch the graph of this function. The piecewise defined, straightforward, but you must be able to do it correctly. So this is it. It's a negative 2x plus 1 when x is less than 1. And it's x minus 3 when x is greater than or equal to 1. You see the function is two partition. So you have to take care of these two partitions. They may be able, you may be able to connect them together. It's going to be one piece, or they may be two different pieces. Okay, so it depends on the given information. So you have to graph each part. Okay, and estimate it up to the one here, up to the one, and over here, one up. Okay, so this is the way we are going to partition it, if you like. So we go with the first one, y equal to the negative 2x plus 1. everything up to 1. So we pick the 2 points. Make sure that you are not going to go over the 1. So we keep the 1. We estimate it up to 1. So if you want to estimate it, that gives negative 2 plus 1, which is equal to the negative 1. So we know that this is not going to be a point on the curve, but we know that it's going to be up to the negative 1 if you like. So something less, which is 0. So you put into the function that gives you 0 plus 1, which is equal to 1. So we are going to graph this part. We get 1, negative 1. It's a 1, and this is negative 1. So we just look, we don't have equality sign. It's going to be up to this point, so we're going to take this point out. Okay, up to this point, but not the point. You see, that's the idea. Then we have a 0, 1. Okay, the other point is going to be 0, 1. So this is going to be 0, 1. Okay, you connect, you can go to the right only, to the left only. So this is going to be the graph of the function of the first part. Any question? So remember, if you don't put x equal to 1, you are out because you are not going to give us a precise graph. Okay, some people, they pick 0. But what would happen between 0 and 1? You see, this graph is up to 1, up to 1. So this is up to 1. So get the 1. If you don't, if it's not including the 1, exclude it. But make sure you get the 1, okay? So that's the first part. The second part, the function is y equal to the x minus 3. And this is 1 up. 1 up. Again, we start with the 1. To estimate it, 1 minus 3 would be negative 2 up. So we go with the 2. 2 minus 3 would be a negative 1. We go back. 1 and negative 2, you see 1. Negative 2, this is going to be negative 2. So there is going to be a, separation, if you like. You start with this one. This one is going to be covered because the equality sign. Okay, then 2 and negative 1. 2 and negative 1 is going to be this point. So you connect this time, we go to the right. Okay, as you can see, 1 up, 1 up. This is going to be your graph. And you cannot have two solid points at the same time. You know that in that case, your graph is not going to be a function. So it's going to be a function if one of them should be out. So just be careful. Give us a nice graph, but you have to identify that you pick these points. Okay, you pick this point and nicely identify it for us. Otherwise, we don't accept it. It's not going to be a complete graph if you don't use it. Okay, any question? And again, if you want to take calculus, this is going to be in every section of that course, every section of that course. So, that's going to be the one, there's another one. If we get time, we talk about it, but otherwise you have it. So that's the idea of the piecewise defined function. Okay, so the evaluation and the function. Number 4, of course, domain of the functions. Okay, we talk about various functions. So we're going to check these domains in a couple of places. Okay, I'll give you 2 questions on the domain because we have kind of 6 functions. Polynomials, rational functions, radical function, 2 parts, and ln function and the exponential function. Okay, so 2 questions on the domain of the function. And the first one is going to be number 4. Okay, so what is going to be in number 4? The domain of the function. Okay, the domain of each function. The first group. Okay, in this case, you have a rational function, f of x equal to, if you get x plus 3 okay, over x cubed plus x. You know that the difficulty about the rational function is going to be where the denominator is going to be 0. So we have the x cubed, you better factor it to see how many factors are going to have. So in this case, if you factor out the x, then the x squared plus 1 is not factorable. So the number would be 0 at one point only, at x equal to the 0, because x squared plus 1 is not going to be, okay, factorable. So this function f is undefined at 0. Interval notation, this is negative infinity, positive infinity, and you take out the 0. Okay, so domain is going to be two partitions, negative infinity to 0, union with 0 and positive infinity. You have to write it on interval notation, and this is the way we are going to do it. Any question? So if it was x squared minus 1, you get positive negative 1 again, so we get 3 numbers. So in this case, it was just one number, so we have, we have two partitions. That's a part 1. The part 2 is okay, something with the odd index is missing. So you know that for the radical function, is the index is odd, this function is okay, the function is going to be defined everywhere. But if the index is even, you have to be careful. Inside the radical must be a non-zero number, which is going to be the case for this one. Okay, so the index 2 is even. So you must force the inside to be bigger than equal to the 0. Okay, so you move the 3 to the other side. So you divide by negative 1, so x would be less than equal to the negative 3. Okay, so this is going to be domain of your function. You have to write down interval notation. You see this is the number line, and this is a negative 3 less than, so you are here. So the domain of the function is going to be from negative infinity up to the negative 3. Okay, any question? So if it was odd, that's you're lucky, that domain would be all real numbers. But this is where it's even, we are going to be concerned. Okay, there was one special case. This is it. H of x equal to the fourth root of x squared minus 9. You see x squared minus 4, 9 minus x squared. These are the one that we investigate. So the index of the radical 4 is even. So again, the inside must be positive. Again, if it was odd, the domain would be all real numbers. So this is even. So you have to force x squared minus 9 to be greater than equal to the 0. You have to solve this inequality. You know that you can use factoring. You did it equal to the 0 to get to a solution, positive negative 3. Then you may draw a chart to identify where this is positive, or remember the shortcut. You move the 9 to the other side. Take the square root. Radical x squared is the absolute value of x greater than equal to 3. Remember the absolute value greater than. So this is a negative 3 and a positive 3 greater than. So you're not going to be between negative 3 and 3 greater than to the right, or the greater than to the left. Okay, so the domain of your function is going to be negative infinity to negative 3, union with 3 and positive infinity. So that would be the domain of this function. We did this one before. It's a very important function. You know that if they switch these two, if there's going to be 9 minus x squared, so your domain is going to be inside. So be careful when you want to pick the domain. Okay, any question? So that is, we have a rational function and the radical function for the domain. We are going to have two other types of the function that we give you on test, probably it was test 3. The other type is ln function, exponential function. So it's a number 12. Just want to get all the topics together. In number 12, they ask for the domain and the x-intercepts. Okay, find the domain and x-int, x-intercepts of these two famous functions. You did on test 3 probably this one. It's a y equal to ln of 4x minus 8. Okay, you know that the ln or the log, it's always defined for the positive numbers only. So you have to force 4x minus 8 to be greater than 0 only, not greater than equal to. Just greater than. Okay, so the solution is going to be, you let 4x minus 8 to be greater than 0. So that gives 4x greater than 8. So x would be greater than 2. So the domain would be 2 up, 2 and positive infinity. That's a domain. Okay, ln log is going to be defined for the positive numbers only. Okay, now x-intercept, you let y equal to the 0, so for x. Okay, so for x-int, you're going to let y equal to the 0. So that gives ln of 4x minus 8 equal to the 0. You want to solve for x, remember you switch into the exponential function. The base is e, so 4x minus 8 is equal to the e to the 0. E to the 0 is 1. So that gives you 4x equal to the 9. So x would be 9 quarters. So the x-intercepts is a point in 9 quarter and 0. So that gives you the x-intercepts. Okay, any question? Again, these are coming in test 3 when we introduce these two function. Okay, this is a log function, and the last one, exponential one, is easy function. So the part B is y equal to the e to the 2x minus 1 minus 1. Exponential function, you look at for 2x minus 1. 2x minus 1 is a polynomial. Domain is all real numbers. Okay, there is no restriction. So the domain is R, done. To get the x-int, you're going to let the y to be equal to the 0. And you have to solve this equation, e to the 2x minus 1 minus 1 equal to the 0. You know that you move the 1 to the other side, and e to the what is equal to, it's going to be equal to, like e to the 0 if you like. So 1-to-1 property, 2x minus 1 equal to the 0, so x would be half. So the x-intercept as a point is going to be the point with the coordinate of 1/2 and 0. Okay, so this is the domain and the x-intercepts of these two famous functions. Okay, so we put them together. These are all the functions that you know, polynomials, rational function, radical function, exponential function, and the ln function. These are all the functions that we study in this course. Okay, any question? So that will take us to that was question number 5 that we did. Question number 5 is about this. Okay, it's a quadratic function. Okay, they ask for the graph, the domain, the range are all one problem. You always identify the vertex and you go for it. There were two cases for these type of questions. Okay, so let's remind you. So question number 5 is going to be about the quadratic functions. Okay, to identify the vertex axis of symmetry, you can graph it, find the max and the mean, and then give us the domain and the range. Okay, there are two possibilities. Okay, the first one is the easy part. There were two formats: -5 times x plus 3 all square minus 1. Remember, if it's going to be this format, the general formula is y equal to the a times x minus h all squared plus k. That was the general formula. In this formula, a would be a -5. We compare. The vertex is h and k. You see the opposite number is a -3 and -1. That's going to be the vertex. Okay, for h, always the opposite, because if you compare them together, you see the negative h is equal to 3, so h is -3. And the k is exactly the same thing. Okay, so this is going to be the vertex. And this is, of course, axis of symmetry. That's it. You can graph it. You preview the graph first. -5 is negative, means graphing down. That would be helpful. So to graph, we locate the vertex. It's a -3, 1, 2, 3, and the -1. So that would be the vertex. The mirror is axis of symmetry. Remember, this is going to be axis of symmetry. Okay, that's that AOS. Now we know that this is going to be the vertex. It's going to be curving down. We need help. Help is an extra point. We talk about it. We can pick the help. Easiest help is x, y. We replace the x by 0 and get the y. You can pick any other number you like, but the 0 is easier. So if you put the 0 here, so it's going to be quite a lot. It's going to be 9. Okay, it's going to be -5 times 3 squared minus 1. 45, 46, it's quite a lot. So, suppose this is going to be the one. Okay, so that gives it a chance that curving, graphing one part of your function. Then use the symmetric property, okay, to get the second part. So that's going to be, the graph of the function. Since a is negative, it's going to be curving down. So the bonus is going, because they ask for the range. So this graph would have a maximum. The maximum would happen here, okay, which is a -1. Okay, the y coordinate of the vertex. So the max of this function is going to be -1. So the range of the function is up, everything up to the -1. So we start from -infinity to the -1. Of course, the domain is always R. So that's all the information that you can pick, for this group of the functions. Okay, any question? So that's case 1. When the function is given to you in its square root form, if you like, complete the square form. And there is another possibility. The form would be different. Okay, so that's a part B. The function is classic format. F of x equal to -3x squared plus 6x plus 1. We call it classic form. Okay, in this case, the vertex is, you have to memorize this formula, negative b over 2a, comma, f of negative b over 2a. Okay, that's formula for the classic one in this form, and the other one is just, the other one is easier to find, okay, to find these numbers. Okay, so what I'm going to do is just identify the a and the b. So a is a negative 3, a is a negative 3, b is equal to the 6. You can find the x is equal to the negative b, the x coordinate. b over 2a, which is a negative, b is 6, 2a, 2 times a negative 3. So that give you negative 6 over negative 6, 2 negative would be positive, that give you 1. Okay, so the x coordinate of the vertex is 1. Drop it into the function. F of 1 would be negative 3 plus 6 plus 1, which is equal to 4. So the vertex in this case is going to be 4 and 1. Any question? So the other one was easily, simplified for you, but this one, we just use classic, doesn't matter. Okay, so they ask for the graph. You preview the graph first, and then the same thing. So A is equal to, oh, both of them are negative. I wanted to have something better, but it's done again. We want it to be up, we can change that sign into positive, but anyway, we know how to handle it. Okay, so there you are. It's the same thing now. 4, 1, 1, 2, 3, 4, 1. So this is going to be the vertex, the mirror, and get help. The help is going to be x, y. For x equal to 0, y would be 1. Okay, so this is
Wait, isn't the vertex 1 4, not 4 1?
oh yes, you are right. That's why I get this one the other way around. Yes, thank you. Yeah, this doesn't make sense now. So 1 4. Okay, so I put it here. We get the 1 4. Okay, this is a 1 4, 1 2 3 4. So this is going to be the vertex. Okay, now 0 1 is here now. So this is going to be which part, and we do the other part. Is going to be 1. Yeah, I wanted that negative to be positive, so we give a minimum. The maximum is it's okay. Okay, so this graph would have a maximum. The maximum is 4. Okay, so the max of f of x is 4. So the range is going to be up to 4. So the range is going to be negative infinity up to 4. The domain of R. Okay, so that gives indication that you must know these function, 2 cases. Okay, we call it the standard, and the other one could be that just the classic. So that was number 5. Any question? The application type, we give you one. We just make one like the cost function, revenue function, which basically is going to be the same thing. So we did have, you better check it. So that is a rational function, number 5. Any question? Number 6, we give you one graph of the polynomial function. Remember, easy graph to talk about it, but you have to take the end behavior and those x-intercepts. So that's number 6. Okay, number 6, we want to sketch a graph of this polynomial function. Sketch the graph. and the polynomial function, which is f of x equal to, okay, we have the x squared times x plus, okay, x plus 2 to the fifth times x minus 2 to the third. Okay, remember this type of function? The graph is very smooth, no sharp corner. So 2 steps to do it. You have to find the end behavior. End behavior means what would happen when x goes to positive infinity and negative infinity. To do it, we need the x with the highest power. So we're going to guess what's going to be the x with the highest power, and we check the infinity on it. Okay, so this is the solution. So we multiply to see what's going to be the first term. You see, when you want to multiply the first term, the highest power of the x from the first one is x squared. From the second one would be x to the fifth, and from here would be x to the third, and then other terms of the function. So if you go on, this is going to be x to the 710. So this is going to be, when we shrink it, y is, you just consider x to the 10. Okay, any question? When x goes to infinity, this is a polynomial. It's just a combination of powers of x. So all the terms are going to be infinity. So we pick the x with the highest power, and we check the infinity in it. Okay, so we go from left to right. If x goes to negative infinity, okay, then y goes to, just check the sign because the result is infinity. Negative to the 10 would be positive, so that give a positive infinity. Okay, this is when x goes to negative infinity. Now if x goes to positive infinity, then positive to the 10 would be positive. So this is where your graph is going to be. Okay, negative infinity, positive infinity, and the positive and the negative. When you move from here, the graph is up, so you are here. Negative, positive, negative, positive. And positive, positive, so you're going to be here. So that gives you an indication where the graph is going to be. It's going to be in the, it would end up in the first and the second coordinate, okay? Quadrant. So that's the first part, the end behavior. Now we check the x-intercepts. You see, remember, if the power of the x is even, the graph would touches the x-axis. If the power of the x is odd, the graph crosses. So we are going to investigate this one, f of x equal to the 0. Okay, so what we have the x squared times x plus 2 to the fifth times x minus 2 to the third equal to the 0. So we check x squared equal to the 0. The power is even, so the graph would touches the x-axis at x equal to the 0. Even touches because there's not going to be a change in the signs. So the next one, x plus 2 to the fifth equal to the 0. So that gives x equal to the negative 2. The power is odd, so crosses. And the other one is x minus 2 cubed equal to the 0. Again, x is equal to the 2, and the graph crosses again. Okay, so now we are ready to graph it. So this is going to be the case. Identify the intercepts: 0, 0, negative 2, negative 2, and positive 2. That's it. You know that you start from here and you end up here. So you start from here, we get to negative 2. Negative 2 is crosses. then we get to the zero touches and the crosses. So we are coming down from here. You see this is it. You cross, okay, you cross and you turn, you go to the zero. At the zero it touches. So you touch the zero, then you turn, okay, you turn and then you go to the next one. And at two crosses, and you go to the first quadrant. And you know that it's going to be up, up. So very, interesting and straightforward question, if you like, to get these numbers done. Okay, that's a number 6. Any question? And number 7, as I told you, is a cost function. It's just a quadratic function that you find the minimum. We did it before. Okay, so that's a number 7. So I give you a short break. We come back and we continue. We get to the equation, and we get to that's the last part of the course that we did. I mean, there are too many questions on this one, really. But basically, we are going to give you 16 out of these concepts. It's nice to know what you expected to know from this course at the end. Okay, 10 minutes, we come back and we do the others. Bye-bye. Okay, so the number 8, solving the equation using those, remember, rational zero theorem that we talk about it. We try to find one of the solution, then reducing the power and just doing it. I just put a couple of them over here, and just to remind you that this property. Okay, so number 8, you want to solve each equation. Solve each equation. Just remind you with one of them. We did these are all in the previous test. So the part 1, the equation is 2x cubed. Okay, 2x cubed plus 11x squared minus 7x minus 6 equal to the 0. Remember, we can check one of the solution because this is cubic. We talk about that zero rational zero product, but I told you that just check to see if you can do it quickly. If the coefficient, sum of the coefficient happen to be 0, one of the solution is 1. Otherwise, that the possibility that we talk about it, that's the leading term. You don't need that idea. Leading term is 2, and the constant term is -6. Then if the solution is going to be of the form of the P over Q, the P is going to be the divisors of the 6, which is going to be positive -1, quite a lot, positive -2, positive -3, and the positive -6, and the divisors of the 2 over here is going to be positive -1 and the positive -2. So if you divide, give you those possibilities. Okay, in this case, it's going to be quite a lot. If you divide the top, positive -2, positive -3, positive -6. If you divide them by 1, and if you divide them by 2, so that give you positive -1/2. Okay, 2 divided by 2 would be 1, and you get positive -3/2. These are going to be the possibilities. But we need to know one of them to check to see if it's going to be the solution. You see, sum of the coefficient is 0. 2 and 11 is going to be 13. Add -7, and that 6 give you 13 again. So that will help you to find out that x equal to 1 is one of the solution. Okay, and you are going to check it. Is a solution. But you have to use the syntactic method to get the shrinking polynomials, if you like. So that give it 2, 11, -7, -6. You bring the 2 down. Okay, and then you to find out what's going to be the other polynomials. So that gives you 6 and the 6, which is 0. So the leftover, if you like, is going to be 2x squared plus 13x plus 6. So your function is going to be so far factored into the x minus 1 times 2x squared plus 13x plus 6 equal to the 0. You can go on and factor this one, and otherwise you want to solve the equation. So you just let it equal to the 0, try the factoring, or just you may use quadratic formula to get it. Okay, so when it's a cubic, really it's going to be easy, and you have these possibilities here if you like to check. But you can use factoring to do it, or just quadratic formula. If you want to factor it, I think that would give you the result. So this is going to be probably, this is 1 and this is 6. You can check. So that gives 6 times 2, 12. It's going to be the two solutions here. Okay, 2x plus 1 times x plus 6 equal to 0, or just quadratic formula. So we have two solutions, x equal to the negative 1/2 and x equal to the negative 6. Okay, so we just give you 1 cubic. You know, in case you want to take calculus in future, you may need it for this quadratic, polynomial equation. The second one is a 4th degree. It takes a little bit more time, but we just give you 1 cubic if you want to give you one question from this part. So that's a number 8. Number 9, graphing the rational function. Just check it for yourself. We did it before. Remember, we did it a couple of times. It got to be in test number 2. So check number 9 from, it's exactly the same thing that we did before. Okay, so that's a 9. And number 10 is a system of the equation, linear and nonlinear. We give you one question on this one. So it's a linear one and nonlinear. So that's number 9. Number 10. Okay, solve the system. Solve the system. So part 1, again we did it, is x squared plus y squared equal to the 9. And the part 2 is going to be y equal to the 2x minus 3. It's going to be nonlinear. So this means you can have two circles. You may have a circle and a straight line like this one. Okay, so the substitution method is the only method that you are going to apply to get this one. So we call this one number 1, number 2. So from number 2, we get the y, which is a 2x minus 3, and we are going to drop it into the number 1. Okay, so it is going to be x squared plus 2x minus 3 all squared equal to the 9. You have to solve this equation. You have to simplify it. Okay, so this is going to be x squared, a square of the binomial, that is 4x squared minus 2 times 3, 6, 12, and 9 equal to the 9. Okay, combine the like terms, so that give you 5x squared, and that's a minus 12x. The 9 and 9 would disappear. Okay, 2 times 2, 4, 12, and they get a positive 9 here. So factor out the x. That give you 5x minus 12 equal to the 0. So you have two solutions for the x. X equal to the 0, one solution, and x equal to the 12/5, the other solution. Is a line would intersect the circle at 2 points. So you can put the x equal to the 0 here to get the y. Okay, so x equal to the 0, you go to the equation number 2, so that give y equal to the negative 3. So we have x comma y equal to the 0 and negative 3. Okay, and the other one, x equal to the 12/5. So we go to the equation number 2 again. So y would be 2x minus 3. It's a 2 times 12/5 minus 3. So that gives you 24/5 minus 3. Okay, so it's going to be 15. And that gives you 9/5. So the other solution is going to be 12/5 and the 9/5. 12/5 and the 9/5 is going to be the solution of your equation. Okay, it's a nonlinear, and this is the one that we're going to be interested in. Remember, we have two sections on this one in your book. Okay, that's a nonlinear. Any question? For the linear, of course, a 3 by 3, and we are interested in Cramer rules. Remember Cramer rules? So this is going to be, it's going to be one question, 2 parts. Okay, so let's remind you that is going to be 10b. In 10b, this is going to be a system of the equation that you have. It's a 2x. Again, it's from the previous test. We just repeat it again. It's a negative x plus 2y plus 4z equal to the negative 3. And finally, it's x minus 2y minus 3z equal to the 4. Okay, remember the Kramer? You have to find the matrix of the coefficient. If it's going to be a non-zero number, then you can find the solution of your equation. So the matrix of the coefficient is going to be this one. We have the 2, 1, negative 1, and that's a negative 1, 2, and 4. And you have the 1, negative 2, negative 3. You get this one? The way we do it, we go across the first row. It's going to be 2 times. We eliminate the first row and the first column. The leftover, 2, 4, negative 2, negative 3, cross multiply. So that gives a negative 6 minus, that's a negative 8 to make it a positive 8. Always minus the second entry, second one. Minus 1. Again, cross these two out. We get negative 1, 4, 1, negative 3. So that gives you 3 minus 4. Then you have this one minus, eliminate these two, so it's a 2 minus 2. Okay, that's a positive minus 2. Now we simplify it. This would be 0. No, that's the 8. Okay, that was 8. Yes. So that's going to be 2. 2 times 2 would be 4. And this is going to be a negative 1, positive 1. And that would be 0. Okay, so that gives you 5. So D is equal to the 5 is a non-zero, so we continue. We get the solution. Now, remember, in order to find the x, we need D sub x. D sub x, you remove the x column with this constant. You get the 3, negative 3, and 4. Everything else is the same. 1, 2, negative 2, negative 1, 4, negative 3, which is going to be equal to, we start with the 3 times, eliminate the first row and the first column, so that gives a negative 6, minus, that gives a negative 8 is a positive 8, minus the second one, so that gives you 9, minus 16, and that gives you minus, so that's going to be 6 minus 8. So that gives you 2. 2 times 3 would be 6. And over here is going to be negative 7, a positive 7. And it's a negative 2, positive 2. So that gives you 15. So the dx is equal to the 15, and we are ready to get the x. Okay, so x is going to be d sub x over d, which is going to be 15 over 5, which is equal to 3. So x is equal to the 3. Okay, any question? So we try to get the y and the z, similar one. Okay, there you are. To get we are going to form the dy. dy, the first column would be unchanged. The second column is going to be that constant column, 3, -3, 4. And the last column is going to be unchanged. So we get this one. It's going to be 2 type. Is 9 minus 16 minus 3 times 3 minus 4 minus, okay, that's going to be -4 plus 3. So what is this one? It's going to be -7, -14. That gives us a +3. And this is going to be a +1. Okay, the result would be a -10. So dy would be a -10. -10. So y is equal to the dy over d, which is going to be a -10 over 5, which is a -2. So y would be -2. Okay. So that's the x, y, and eventually we get the z. We need to find the d sub. Okay. dc. The first and row and the second row would be unchanged. So we get the 2, -1, 1, 1, 2, -3, or -2. So we change the third one. And we're going to get this one done. Okay, so it's going to be 2 times. It's 8 minus -6, always minus. That's a -4 plus 3. And plus 3 times, okay, that's a 2 minus 2. So that gives you 4 plus 1, and the other one would be 0. So that gives you 5. Okay, so z is going to be dz over d, which is a 5 over 5, which is equal to 1. So we get the triple as a solution. Okay, we give one of them. It's not bad, takes times, but it would be a straightforward question, really. So that is number 10. Just to remind you that Kramer rules. Again, one section of the book. So we have to check it. That's number 10. Number 11, sketch the graph of the point y is defined, that we talk about it. Number 12, domain and the x-intercepts, we talk about it. And number 13, we create something. We did this one before, that logistic model. We create something and we ask you to use your calculator, okay? Just make sure you are ready for it. This is going to be exponential function and just getting those numbers out. Just double check. You did all right with one of them that we discussed. Okay, the population, growth of the population one. So that's the same thing. And we did it before. Number 14 and 15 are going to be equation of the exponential equation and the log equation. We give you one question, it's 2 parts, one each of these. So 14 and 15 together as one question. Just put a couple of them as a sample to remind you, and you know it. You want to solve this equation. The first one is the one that you have to use the one-to-one property to get these numbers. is a 32 to the x. Remember, if you match the base, then you'll be ready to let the top to be equal to each other to get the result. And we did this one before. 4 is 2 squared, 32 is 2 to the 5th. Then we simplify those double exponent, and then you'll be able to do it. Okay, so that was the idea. This is a 2 squared negative x plus 14. And that's a 2 to the 5th to the x. A double exponent, you multiply, or multiple exponent. This is it. Now you match the base, so the top must be the same. Okay, it's going to be 2, this is it, to negative 2x plus 28, and that's a 5x. Solve for x. 28 equal to the 7x, and the x equal to the 4. Okay, so that's the idea for these type of problems. Okay, any question? A second one is a kind of quadratic exponential function that we talk about it. We have a better format of this one before, but this is not bad. The type of those application type. Okay, it's from your book. You want to solve this equation, e to the x minus e to the negative x over 2 equal to the 7. You have to simplify it to get a quadratic to be able to do it. So cross multiply. Okay. If you cross multiply, that gives e to the x minus e to the negative x equal to the 14. Okay. So if you remember, what we did is you have to change this one into the 1 over e to the x. Now multiply e to the x to get rid of the denominator. Okay, multiply both sides by e to the x. So e to the x times e to the x would be e to the 2x. This would cancel out to get the 1, and that would be 14 e to the x. Anyhow, we give you a straightforward one to get to the quadratic right away, but this is just from your book. So that would be e to the 2x minus 14 e to the x minus 1 equal to the 0. This is, this is the result that we gave you on the previous test. You know that it's quadratic. The one that you did have was easy. You factor it right away, but this is from your book. It's not possible to factor it. So you may have to use quadratic formula to take care of it. Okay, so if you take the u to be e to the x, then u squared would be e to the 2x. So you have something like u squared minus 14u minus 1 equal to the 0. So, because you cannot factor it, you have to change it to the, to u type if you like. Then take care of it, quadratic one. So delta is going to be negative 14 squared minus 4 times AC. Okay, so that gives you, it's not going to be a perfect square one. So 14 squared is 196. 196, and this would be 4. We get 200. It's positive, but it's not nice. Bad and not big deal. The one that we are going to give you going to be a nice one, but not bad to get these. Okay, it's going to be negative b, negative 14, plus or minus radical 200 over 2 times 1. So it's going to be 14. What can you do about 200 is going to be 2 times 100, so 10 radical 2. divided by 2. You just only, sorry, that's u. You just simplify by 2. So u would be 7 plus or minus, okay, 5 radical 2. Okay, that's one. You can use your calculator to get this number and continue. Okay, so the case is going to be, you see, that's u. You have to find the x. So if you pick u to be equal to the 7 plus 5 radical 2, so that gives e to the x equal to the 7 plus 5 radical 2. You have to bring the x down. Remember, x is ln of 7 plus 5 radical 2. We can use calculator to get it or just leave it as is. This is going to be one case. And for the second case, you are not going to have any solution because if you use your calculator, this number is a negative number. E to the x, this number is negative, so there is no solutions. If you check the one that we did for the previous practice test or on your test, the number was nice. It was e to the 2x, I think, minus e to the x minus 12. So you were able to factor it. So we give you something similar to that, but this is from your book. Just wanted to know that, if sometimes you may need to use quadratic formula to take care of it. But otherwise, it's called quadratic exponential function. So you may see this quadratic exponential function. Okay, that's number 14. Any question? Number 15, choose ln function, ln equation. Again, very standard, and we did it before. It's going to be one question, part 1 exponential, part 2 one of these ln function. Okay, a straightforward one first. Log of 3x minus 1 equal to the 5 at base 2. This is the one that we did on the test. You remember how we're going to do it? When it's a single log, we just switch. We switch to the exponential form. 3x minus 1 is equal to the base 2 to the 5th. The one that I gave you on the test, the base was 10. Here's something like 10,000 something. But this would be just 32. So the 3x equal to the 33, and the x would be 11. So that's a part 1. Okay, any question? The part 2 is always done that you have to change it into the single log. So they may give you a sum or a difference. In this case, this is a sum. So you can do it if you have a single log only, but this is 2 log. So we change it to the single log. Remember, if we change to the single log, if it's positive, the product. If it's a negative, the quotient. So that's the idea. The log, it's x plus 4 times x plus 1 equal to 1. Now, same thing here. But over here, the base is 10. So x plus 4 times x plus 1 is equal to the 10 to the first power. Now you have to, use the FOIL method, simplify, and then try to solve the resulted equation if you can. So that gives you x squared plus 5x plus 4 equal to the 10. Subtract 10. Okay, that gives you negative 6 equal to the 0. Now solve this equation, which is possible. Okay, x minus 1. So we get x equal to the negative 6 and x equal to 1. And you know that. It's a ln equation and you have to check the solution to make sure that you are not going to have ln of a negative number. If you check x equal to negative 6, of course, we get ln of negative 6 plus 4 would be log of negative 2, which is undefined. Or here, it doesn't matter. So if this is going to be the case, one of them would be fine. Log of x plus 1 would be log of negative 5 and defined. Because the log is defined only for the positive numbers, okay? It's going to be defined only for the positive numbers, okay? So this is not going to be the case. So we check the other one, it's fine. X equal to 1 is going to be fine. Okay, so we get only one solution. Okay, any question? So this is going to be log equation. Number 16 is the same as the one that we did before. Okay, this is a typical, exponential equation that you did on your one of your quiz. Number 17. 17 composition of two function. Okay, part 1 composition of two function, and the other one is going to be the inverse function. You should be fine with this one. Okay, number 17, we did both of them, and the partial. I want to do one problem is quite different. I want to explain that one first. That's 17 partial. Okay, partial decomposition. Then everything else is like the quiz tonight. Okay, five first terms. We did this one, all part of your quiz. I'm going to explain this 23 for you, which is a little bit different from the others, to make sure you don't miss it. This is going to be a kind of application problems for the sequences. That's much, much better. You have a couple of them in your book, in fact. Okay, let's see what is the difference between this problem and the one that you did on the quiz. Okay, so that's number 23. What's 23? You see, it's a straightforward problem. You save money in the bank. The bank gives you 6% interest. Okay, so it's a rate of going to be, rate that the bank is paying you is 6%. Okay, so what do you do? You open an account with the $1,000 in it. Okay, you can, you can call it P or A, it doesn't matter. Okay, if you want to stay with the A0, so it's going to be $1,000. Initially, you put this one into the bank, okay? In addition to the interest that the bank pay you on the last day of each year, you go to the bank and you put $200 more. Okay, at the end of each year, you go to the bank. You are not going to touch the money. You leave the money in the bank. You leave the money in the bank, and then you put $200 more in it. Okay, so what we'd like to do is, we would like you to write a recurrence relation, or if AN is going to be. You see, if AN is going to be the money in the bank. Okay, this is going to be your money. Okay, it's going to be your money at the end of n years. We want to find a relationship for this AN. You see, this sequence is going to be a recursively defined sequence. We want to find that equation for us and tell us how much money is going to be in the bank at the end of 5 years, which is easy. You want to find the A-fifth. Okay, so you start with the $1,000 in the bank. The bank give you 6% interest. You go to the bank at the end of the year and you put 200 more. Then you come back the next year, you do the same thing. You're not going to touch the money is in the bank. Okay, but you put $200 again. So we want to know what is going to be the formula for your money at any time. Okay, anytime you like it. You see, the quickest way to do it is this one. Look at this one. Just want to get to know these ideas. This is the money after n year. So what's going to be your money? You go to the bank. How are we going to calculate your money? Your money is going to be your money in the previous year, an minus 1, like the one that we did for the quiz, plus the interest. How much interest? 6%. 6% of an minus 1. But what do you do? What do you do? You put $200 more in it. $200. Okay, so you go to the bank, you calculate your money. Your money is the money in the previous year, an minus 1. Okay, plus 6% interest. So what you did, you add $200 extra in it. So what's going to be the result? This is an. This is an minus 1. 6% is going to be 0.06 an minus 1 plus 200. So an, the money in the bank, is going to be, you combine these two together, 1.06 an minus 1 plus $200. This is going to be a relationship between your money, okay, a recursively defined sequence, if you like, for your money in the bank. Your money into the bank, okay, so of course you can say that this starts from what? It starts from n equal to the 1, 2, 3, etc. with the initial value which is going to be A0, which is going to be $1,000. This is going to be a relationship of the, you see the one that you did on the test was this one, because you didn't put the money in the bank, an extra money. Now you put an extra money, which is going to be $200. Okay, any question? So you go to the bank, you don't touch the money. The bank gives you 6% interest. You get the money in the previous year plus your 6%. But you put $200 again and you come back. So if you want to find your money anytime, is anytime an, is going to be money in the previous year, 1.06, the previous years plus 200, for n equal to the 1, 2, 3, a0 equal to the 1,000. That's the equation. What they want to find, a5. Okay, a5, this is the way we're going to do it. Any question? These type of arguments are very, very popular. It's like, you get a raise each year, 6% raise, and there is going to be a commission, or, that they pay you as well. So that's going to be a relationship, a sequence that give you the number. So if you want to find the a5th, this is the way we're going to do it. It's like writing the first 5 sequence of this problem, okay? So I write the equation over here and I find the a5th value. So an is equal to 1.06 an minus 1 plus 200, with the condition that initially you have $1,000. So replace n by 1, a1, at the end of the first year. You get 1.06 a0 plus 200. Your money in the bank plus the $200 that you have. A0 is 1,000. 1.06 times 1,000, okay, plus 200. Use your calculator to see what's going to be this number. So A1 would be, if you multiply this, it's going to be 1,060 plus 200. So at the end of the first year, you get $1,260. This is your money in the bank after the first year. Any question? Remember, you want to find what will happen after 5 years. A2. You repeat the formula again. A2, 1.06 times A1 plus 200. What's the A1? 1.06 times A1, 1260 plus 200. So that gives A2. What's A2? You see, this is going to be, you can find a formula for all of them. It's a kind of a geometric sequence, but we want to check 1.06 times 1260, okay, plus 200. So this is going to be your money in the bank after 2 years. 1535.6. That's the A2. Okay, you repeat it again. What's going to be A3? A3 is going to be 1.06. Okay, A2 plus 200. Substitute 1.06 A2, 1535.6 plus 200. Again, use your calculator. And the previous one you multiply by 1.006 and plus 200. So that gives you the number. It's going to be 1827. Okay, 27.736. So it's going to be A3, the money after 3 years. Money after the 4 years is going to be 1.06 times A3 plus 200. So we multiply that number by 1.06, okay, plus 200. So that gives you A4. Sorry, I have to write it down. 1.06 times 1827.736 plus 200. You can use your calculator, you don't have to write all the details. That's going to be 2137 point, I call it 0.40. And eventually, the fifth one is 1.06 times A4 plus 200. And if you substitute 1.06 times 2137.40 plus 200. So you have it in your calculator, you can multiply it nicely and get the 200. So that's going to be the money in the bank after 5 years. 2,465.64. So if you don't touch the money, this is going to be your money in the bank after, okay, after 5 years. This is a kind of application of sequences or recursively defined sequence that we usually, we usually apply in various parts. Mostly in computer science, they use this type of ideas. But it's nice to know, okay? So that 5 question on the quiz, we repeat it again. 5 out of those 16 questions that you have from this collection, we put some of them, some of them together really to give you the example. Okay, so study what you did for the previous quiz, and you should be fine. And that's it. Any question? So we give you 16 questions. We used to give 20 questions. Okay, but we give you just 16. We give you something short really to be able to do it in 2 hours. I did most of them. It doesn't mean that You're going to have all of them, but that give an idea. That's here. Just refresh your memory regarding the first three, really, those quotient difference, piecewise defined function, and the domain of the function. You need to remind yourself, but for the rest, you should be fine. Okay, so don't be late. We need that 2 hours to be able to do it. Okay, have a good one, and see you on Wednesday.